Okay, let's look at 10.3, or simplifying radicals. So last time we looked at square roots, and we talked about our square roots being that the square root of 4 is equal to 2, because 2 times 2 is 4. The square root of it is equal to 2. It's what number times itself would give you the number inside there. So square root of 9 would be 3 times 3. So your square root of 9 is 3, and so on. And you can get them by just listing your numbers and then squaring them. 2 times 2 is 4. 3 times 3 is 9. So you can always have these written down beside your paper if you want to. And so let's look at this first one. So if you know the square root, you want to simplify it. If you don't, then you want to leave it under the radical. So this square root of 5 over 36, you don't really have to show this step, but this is the same as the square root of 5 over the square root of 36. But we don't know the square root of 5. It's not a perfect square. If you put that in a calculator, it would be like a decimal. So we don't know what the square root of 5 is, so we leave that a square root of 5. But we do know what the square root of 36 is. That's a regular 6. So you simplify the radicals that you can, and you leave those radicals that you can't. So this next one, so again, you don't have to show this step, but this is the square root of x over the square root of 49. We don't know the square root of x. In fact, we'll talk about that here in a minute. So we're going to leave that under the radical, and then the square root of 49 is 7. So let's go over here and talk about the square root of variables, or the letter x. So we learned last time that x to the n over m equals to m the square root of n. Now you don't have to show all these steps, but I just want to show you where this comes from. So when we look at this first one, this one's like a 2, because if it doesn't have a square root, it's meant to be a 2. So that means 2 is m, and our exponent is 2. So you could rewrite this backwards to say that that's x to the 2 over 2, and 2 divided by 2 is x to the 1. This one, the same thing. This is like having a 2 there. So you could rewrite this to be x to the 3 over 2. But you see that 3 over 2 is really 1 and 1/2. So what that does is it brings one x out, and it leaves one of them to the 1/2. And remember, the 1/2 is the square root of x. So the shortcut really here, you don't have to show this step. What I want you to realize is that when you have a second root, you're really dividing everything by 2. 2 divided by 2 is 1. 3 divided by 2 is 1 with 1 left over. It means 1's going to be inside the square root. Or x to the 4th, you're really just dividing it by 2 and saying 4 divided by 2 is 2. But when you take 5 divided by 2, 5 divided by 2 is 2 would come out and 1 would stay in. X to the, I skipped x to the 6 there. X to the 6 would be 3. But then x to the 7th, 2 would go into 7 3 times with 1 left over. And then x to the 8th, 8 divided by 2 is 4. And again, I left out the square root of x to the 6, but that's just x to the 3. So what I want you to think about is you're dividing by 2. Now I know this sounds really silly, but this seems to help people remember how the square roots work, is that you think about a square root as like being a house. So say you have 2 people in this house, and the law says you can only come out as a couple. So do you see, one couple could come out, one group of 2 could come out. If you have 3 people in the house and only one couple could come out, do you see, one couple would come out, but it would leave a single person left behind. They can't come out because they're not in a couple. When you have 4 people in the house, 2 couples can come out. But when you have 5 people in the house, 2 couples could come out, but it leaves that single person behind. So the square root, the 2, shows that you can only come out in groups of 2. Okay, so then let's look at cubes. I shut that off so I could write some more here. But so if you're thinking about the cube root, do you see here we were dividing by 2. 2 divided by 2 is 1. 3 divided by 2 is 1 with 1 left over. 4 divided by 2 is 2, and so on. When you have a cube root, then your bottom number, your m, is a 3, so you're dividing by 3. So for this first one, you would say 6 divided by 3 is x squared, because 3 will go into 6 2 times. But when you get to 3 into 7, 7 divided by 3 will go in 2 times, but it's going to leave 1 behind because you, whoops, inside the square root. Because so this is now saying you have to come out in groups of 3. So only people can come out 3 at a time. So if you have 6 people, we'd have 2 groups of 3 come out. But if you had 7 people, you'd have 2 groups of 3 come out, but 1 would be left inside. If you had 8 people inside, 2 groups of 3 could come out, but you see you'd still have 2 people left inside. And if you have 9 underneath, 9 divided by 3 is 3. So again, they can completely come out. So with a square root, even numbers always come out. With a cube root, multiples of 3 can come out. 6, 9, the next one that would be even would be 12, and so forth. So we'll talk a little bit more about square root of variables. So let's go back to this one I skipped. So this is the same as the square root of x to the 8th, which is going to be x to the 4, because 8 divided by 2 is 4. And then the square root of 9 is 3. So like I said, you don't have to write that center step. If you don't want to, you can just square root the top and square root the bottom. Okay, but now let's look at this next one, the square root of 18. That is not a perfect square. We can't simplify it by just looking at this list. And if I ask you, I was a kid and say, if I held a gun to your head and asked you what's the square root of 18, most people would have no idea and they would lose their life. But so we're going to simplify this to make it easier, or if I said point to it on the number line, you wouldn't really think about where it would be on the number line. So we're going to simplify this to make it easier to realize approximately where it's at. So to do that, we look at the square root of 18, and we're going to look at this list of perfect squares because we want to break it up into something we know. And we know the answers for all these square roots. So we look at 18, and it's always best to start where 18 falls. 18 would fall between 16 and 25. And then you work yourself backwards to see what would divide into 18. 18 divided by 16 doesn't work, but 18 divided by 9 would go in 2 times. So we're going to break the square root of 18 up to be the square root of 9 times the square root of 2, because 9 times 2 is 18. Now this first number has to come from this list, or it's not going to do you any good, because there's other multiples of 18, 3 times 6, but we don't know what the square root of 3 is, and we don't know what the square root of 6 is, so none of those answers are going to help you. You want your first square root to come from this list. And the reason why is, now we know the square root of 19 is a regular 3, but we don't know what the square root of 2 is, so it stays inside the square root sign. And so that's in simplified form, because if I told you to point to where 3 square roots of 2 is on the number line, you'd come pretty close to point to where it was at. So we're simplifying it into a number that makes a little bit more sense. So let's try 48. You could always break it up to other factors, but we want to look for numbers on this list. Now this one comes up a lot because there's actually 2 things that'll work for 48. And so when you're picking a number, start with your number. 48 would fall right here between 36 and 49, and work your way backwards. 36 won't go into 48, 25 won't go into 48, but 16 will. You want the biggest number that will go into 48. So this would break up to be 16 times 3. The square root of 16, we picked that because we know the answer is 4. So the square root of 16 is 4. We've got a square root of 3. Now the reason this one shows up a lot is because 4 will also go into 48. But I want to show you what happens. This is the way you want to do it. It's the faster, easier way. But let me see if I have another color pen. But say you broke up that to be 4 times 12. You could still get the right answer there. The square root of 4 is 2. But the square root of 12 is not in simplest form because that would break up to be another 4 times 3. The square root of 4 is a regular 2, so it has to multiply by that 2 out front and become that square root of 3. So that one takes a lot more work. So if you'll get in the habit of working backwards from where it falls on the line, it'll make things much easier. So let's try this next one, 32. So what I mean by that is come to where 32 would fall between 25 and 36, and then go backwards and use the first one that divides into 32. So 25 won't, but 16 will. So 32 breaks up to be the square root of 16 times the square root of 2, and that's because 16 times 2 is 32. And then the square root of 16 is a regular 4, and that square root of 2 comes down. Okay, this next one, first we look at our square root. The square root of 36, that's a perfect square, so we know the answer to that is 6. So the square root of 36 becomes a regular 6. And then the square root of x to 8, remember when you're square rooting, you're dividing by 2. So 8 divided by 2 is x to the 4. Or in other words, if you have 8 people in the house, 4 couples can come out. Okay, the next one, the square root of 25. We know that, oops, I got it off the, we know the square root of 25 is 5, so that comes out as a 5. We know x to the 4, 2 will go into 4 2 times. But now 2 will go into 5. 5's an odd number, so 2 will go into 5 2 times with 1 left over. So I didn't say this up here, I should have, but even numbers, everything will always come out when you're doing a square root. And odd numbers, it's always going to leave somebody behind. Just like, you know, when you're at a party and you have to couple up, if there's an odd number, somebody's always going to be left behind. So you can do a quick glance and know that all the x's are going to come out, but one of the y's is going to be left behind because it's an odd number. When we look at this next one, do you see x and z is going to be left behind, but y is going to completely come out because these two are odd and this one's even. But before we get to the letters, let's do our 50. We don't know the square root of 50, so we come over here to our thing. So 50 would fall right here between 49 and 64. So we work backwards. None of those will work until 25. So 50 breaks up to be 25 times 2, and that's because 25 times 2 is 50. And so when you've got one mixed up like this, you're going to have some stuff inside the square root and some stuff out. So the square root of 25 is 5, so it comes out, but the square root of 2 stays in. Then we're going to look at our letters. Remember, you're dividing by 2. So if you have 5 people in the house, 2 couples can come out, but 1 single person is going to be left behind. If you have 6 people in the house, 3 of them can come out because there's 3 couples. And then for my Z, if you have 7 people in the house, 3 couples can come out, but 1's going to be left behind. So what you're doing is saying 7 divided by 2 is 3 with a remainder of 1 left over. Okay, let's look at these next ones. So 75. Again, we're going to look over here. 75 would fall way down here, but as we work backwards, 64 won't go into it, 49, 36 won't, 25 will. So 75 breaks up to be 25 times 3. Again, some things are going to be inside the square root, some things are going to be out. So the square root of 25 is a regular 5, that came out, but the 3 stays in. I'm leaving room because anytime you have letters, you're going to have some stuff come out. And then you say even, everything's going to come out. 4 divided by 2 is 2. But odd is going to leave something behind. So 2 will go into 7 3 times with 1 left over. So again, 7 people in the house, 3 couples can come out, but it leaves 1 single person behind. Okay, this next one, 20. So again, I'm going to look where 20 starts here on the list here. So when I work backwards, 16 won't go into 20, 9 won't go into 20, but 4 will. So I'm going to break this up to be the square root of 4 times the square root of 5, because 4 times 5 is 20. So again, some things are going to come out, some things are going to go in. So the square root of 4 is a regular 2, but the 5 stays inside. And now our x and our y are both even. So what that tells us is everything is going to come out. So 2 will go into 6 3 times. 2 will go into 8 4 times. Didn't write that very well, but okay, and then these last 2 are cube roots. So I just want you to think about those. I slid over here and wrote our cube roots. Whoops, let me pull them down now. And so we talked about our cube roots last time too. So the cube root of 8 is 2 because 2 times 2 times 2 is 8. The cube root of 27 is 3 because 3 times 3 times 3 is 27, 4 and 5 and so on. So we're going to do these the same way. So first of all, this is wanting to know the cube root of a negative 32. Remember, you can take the cube root of a negative. You can't a square root, but you can a cube root. But 32 is not a perfect cube. So what we have to do is come over here and see which one of these numbers would divide into 32. And the answer there is 8. So the cube root of a negative 32 breaks out to be the cube root of a negative 8 times the cube root of 4. Then we know the cube root of negative 8 is a negative 2. Again, a cube of a negative is negative. An even root is not real, but because 3 is an odd number, we can take the negative. So it's a negative 2 cube roots of 4. And then this last one, when you have a negative on the outside, it's just going to keep coming down for the answer. But now we're looking at 64. Well, that is a perfect cube. So the cube root of 64 is a regular 4. So that, actually, I don't need this down here. That comes out. And now we're going to divide now by 3. Up here we were dividing by 2, but here we're going to say 9 divided by 3 is 3. So T3s can come out. But then V11, 3 will go into 11 3 times, but it's going to leave 2 over because 3 times 3 is 9. So we have 2 left over, so that has to go in as a V squared cube. Whoops, I got to put my cube root there too. So 3 come out, 2 stays in the cube root. And so that's 10.3, simplifying radicals. Try those practice problems in 10.3, and I'll work any of them you need help on the next day in class.